Hello, Algebra Light students. Mr. Lawrence here, and I'm going to go over that flow chart that we came up with class again the other day. Just going to go over it one more time. It says flow chart video January 11th, but this is actually going to be viewed on the 12th for those of you not going, and those of you going to the field trip, you should definitely check it out. All right, so first of all, the first thing I do is step one, check the slopes, right? And if I check the slopes, I know, are the slopes equal? If they're not equal, I know the lines will cross exactly once, therefore there's one solution. Okay? If the slopes are equal, then I'm going to go check the y-intercepts. I ask myself, are the y-intercepts equal? If they're not, I know that the lines are parallel and there's no solution. If they are equal, yes, the lines are the same line and there are infinite solutions. So I'm going to use this flow chart here to help me determine how many solutions a system will have. So let me come down here to problem number one. There's my system. Both equations are in slope-intercept form. Yay for me, because that means I have less work to do. And I'm going to find the slope of the first equation, and it looks like that's going to be 2 over 1, or 2, right? Y equals mx plus b. And the slope of the second equation is going to be 3 over 1. Okay, and so therefore the slopes are different. Now, what does my flowchart tell me? Well, my flowchart tells me that since my slopes are not equal, no, they're not equal, the lines cross exactly once, there's one solution. Now, this doesn't tell me what the solution is. I could graph them both and find out where they cross, but it tells me that they are not equal to each other. Okay, let's try the second one. Yay, they're both in slope-intercept form again. So I'm going to find the first slope, and that's going to be 4, or 4 over 1. Sorry, that's supposed to be an equal sign. I'll find the second slope, and that's going to be 4 over 1. Okay, so this is a different situation. Let's go up to my flow chart. And it says, are the slopes equal? Yes, they are. Check the y-intercepts. Okay, let me go check the y-intercepts. Let me come back down here. Man, I'm getting tired from all this going up and down and up and down. All right, the first one, the y-intercept, looks like it's occurring at the point 0, -3. Okay, that's the first y-intercept. The second y-intercept, the one for the second equation, I should say, is going to be 0, -1. Now there was a question under there. Are the y-intercepts equal? No, they are not. These lines are parallel and have no solution. So I know that the first problem has one solution. One solution. Right? This one has no solutions. The lines are parallel. How do I know they're parallel? They have the same slopes and different y-intercepts. That's what makes them parallel. All right, coming down here, problem 3. I like the first equation because x or y is alone, and so that's in slope-intercept form. I can say the first equation, the slope is 1/3. However, the second equation I have to manipulate. So I'm going to rewrite it as x plus 3y equals 12. And the first thing I'll do is subtract x from both sides. Subtracting x. My left-hand side becomes 3y. And my right-hand side becomes -x plus 12. Okay, now y is not alone, so I'm going to divide by 3. Divide by 3, and divide by 3. So my new equation becomes y equals -1/3 x plus 4. So the slope of the second equation is -1/3 x. Oh, excuse me, -1/3, which is not the same as +1/3. No, one's negative and one's positive, and so therefore I can say the slopes are different. This system must have one solution. So I'm going to rewrite these 3's. They just didn't look good. There we go. That looks a lot better. So I've got a positive 1/3 first slope and a negative 1/3. All right, let's go over here to number 4. It looks like I've got to get y alone in both equations. So give myself some room, and I'll go 2x plus 4y equals 8. Now, some of the people in after school the other day, I think Mason, Noah, and Mackenzie, they were dividing first, which I'm not a huge fan of, but it's not wrong to do that. So I'm going to divide by 4, I'm going to divide by 4, and I'm going to divide by 4. And when I do that, I'm going to get a 1/2 x, just simplify 2/4, plus y equals 2. It's supposed to say y there. Oh, it looks even worse. I don't know what that looks like. Let me rewrite it. Okay. There we go. And now I'm going to subtract 1/2 x from both sides. So then y is going to equal, oops, I lost my x there. Sorry about that. Negative 1/2 x plus 2. So the slope of this first equation is going to be negative 1/2. Okay, now I normally wouldn't erase work, but I want to be able to show the work in the same place. So I'm going to come down here and erase this so that I can get y alone in the second equation. And it looks like y is almost alone. It says 6y equals 3x plus 12. And so on this one, I'm going to divide by 6, divide by 6, divide by 6, and that'll get me y equal to 3 divided by 6 is 1/2 x plus 2. So the slope of this second equation is going to be 1/2. So again, the slopes are different. There must be one solution. One solution. If the slopes are the same, I'm going to check the y-intercepts. If the slopes are different, I know there's one solution. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.